recording is starting now.
It would involve using IP tables, correct?
Okay, all right. So it's it's recording now. Okay. All right, so the question is, exactly, you follow Mitch's video, right? You follow Mitch's video and you create this environment, it makes it into a router. You can ping from one end to the other. You open a browser, as long as you have Apache here, it works, right? So, but port forwarding kind of requires this to be more of a firewall. So then, SAC, what were you saying? What do you do?
You would use IP tables forwarding syntax, correct?
Forward chain, right? Exactly, the forward chain. Because the forward chain was established that it controls from one network interface to the other network interface, correct? And so now you put in a rule there, and now it blocks everything. What's the easiest thing? Well, go into the forward chain, obviously of this one, right? LVM2. And what do you say? In the number one entry, you just say drop all. You know, drop all, basically. That'll just drop all by default, right? And so now nothing will get through. Now, if you remember, I gave you for the port forwarding lab, I gave you two rules, right? If you remember, one was pre-routing. Pre-routing does not have to do anything with the forward chain. But what does it relate to? It relates to the mapping that when something comes in here, it should be, you know, like spoof, right? You're going to change the IP and the port number to be something in your internal network. Does that make sense?
Yes.
Okay, perfect. So then that rule is, you know, perfectly fine. And then the other rule, though, the other one that I gave you is the one related to the forward chain. And all you have to do is make sure you put that before the drop all so that it'll hit that rule for that specific case. Otherwise, it does not allow anything through. Okay? And so you need to make sure that you think about that correctly, because one aspect of this is, remember that traffic is going in both directions, right? So you need to make sure that you allow traffic to go in both directions, but that's basically it, okay? So then what's gonna happen is, remember, pre-routing just says something like open port 8000, I think it was. I can't remember exactly, but port 8000, right? So when you go to the browser, make sure you put 8000 there, right? On the browser, for instance. You come into this packet, pre-routing grabs it and modifies it to what? This one and port 80, right? Port 80. Also, since you don't know what the internal network would be, you would probably just hit not that one, but 192.168.10.1. Does that make sense, guys?
Yes.
All right, that's it. I mean, that's literally it. So you go to 192.168.10.1 on port 8000. Pre-routing will map that to 192.168.27, let's say on port 80, because it's running Apache. And that's done perfectly. However, you still need to allow it through the firewall. So you have to think about that, right, a little bit. Now, I say drop all here to kind of give you an intuition, but you could make it a little less restrictive than that, because really, ultimately, it should only block traffic going in from the outside. Remember, this is technically like the less trusted internet. This would be the internal company. But really, it doesn't have to be drop all. It can be drop all that originate from the outside, for instance. And so hopefully this gives you more clarity on how to do the port forwarding lab, or problem, sorry, of IP tables. Are there any additional questions about this one? Any questions? Is it clear enough? I think I captured the, all the recording. It was necessary. Yeah, so just, I guess what the part I didn't record was, remember, go to the course website, and then here we added a new link, set up VM as router. So that has a 12-minute video that shows you how to configure 3 VMs to have this configuration here. And then after that, you can just play with, again, remember, the video makes it a router, and you just have to use iptables to make it into a firewall. Okay, that's pretty much all it is. But after that, you do have should have a firewall. And then remember also, you don't need to drop all packets, only because technically the packets that leave the internal network should be allowed through. It's only the ones coming from the outside. All right, and that's it. Any questions on this one?
So the IP tables lab got pushed back a week. Is it due the same day as the firewall lab, or is that the firewall lab getting pushed back?
That one we can talk about it next week.
Okay.
Yeah, so definitely right now, the IP tables one, the 8 problems, is pushed back 1 week. And then the other one, which is the last lab, the one I just talked about, right? The firewall evasion. I mean, I think that's a very easy lab, so you should be able, there's only 2 problems on it. Take a look again. Right, that's this one, sorry, this one. And you just have to, read through at least this document, basically. If you don't want to read all 3, at least this one. And the 2 problem scenarios are here, right? So, and the instructions, all the commands are in the PDFs. Okay. So if you can do both by next week, that'd be great, but submit them separately. Otherwise, we might push it back, yes, since it's the last lab. All right, any other questions about homework? So it's your opportunity. So today, if you don't have questions about these labs, I'm just going to continue with the lecture on VPN. Anything else? Any other problems? Any of these problems? Anything?
Yeah, for 3, I'm having problems with putty working.
With putty working?
Yeah.
Okay, what do you mean by that?
What's that?
What do you mean by that? Putty is just an application that you install on the Windows side, correct?
Right, but I try to put the IP address in, and it gives me like an error when I try to run it.
Okay. Can you share your screen?
Yeah, give me 1 minute.
I think for that one I went back and.
All right, so it's now recording. All right, so if you want to start reading this, given that I didn't hear any more questions on IP tables or the 2 problems of firewall evasion and proxy firewalls, we're going to continue the final lecture, which will be, between today and next week, right? I'll just wrap up the course. And in particular, it talks a little bit about virtual private networks and how that works. So as I motivated on Tuesday, it's kind of like port forwarding, right? It's kind of like port forwarding, but more advanced, obviously. There's the elements of routing, but there's also the cryptography aspect of it. You can read through, the PDF is here. I've loaded the link. You can just click on it. So, start reading through this, I'll talk about this. As you can see, it's kind of a more complex network. So it would be similar to the video that Mitch provided for us, right? We have, except that now instead of one router with two network interfaces, it's like we have two, one here and one here, right? And then we have machines on both ends. Okay, so we'll talk a little bit about how that can be implemented from scratch, and then I'll conclude at the very last set of lectures on how that's usually done with a device. So if you purchase a network device, it's going to be as easy as just running a wizard and configuring everything. But here we're just going to kind of from scratch take a look at how it works. So definitely take a look at these documents. We'll talk about a little bit about TuneTap today. It's pretty interesting feature, right? But pretty much everything that I'm saying today is here in the PDF. So you can take a look at it. All right, it's pretty detailed. As you can see here. All right, it's, a lot of very, very fun thing. Definitely this, again, you'd have to do this with Workstation for those of you that want to, VMware Workstation, for those of you that want to do this as bonus points. Again, if you want to do this, I should say, you don't have to do this whole PDF, right? You just have to show evidence that you did implement some of it. And that requires a lot of the routing rules, right? And getting a little bit of the C code to work to send at least one packet from here to here that is encrypted in some sense. All right, so now that I've shown the last module there on VPN, right? These ones that are called ASA just relate to Cisco. So in the very last lecture, I will do a PowerPoint presentation, kind of talk about these. All right, so now I think we are ready to talk about VPN. All right, so I'm going to go back to the whiteboard. The whiteboard. And I always like, before I go into the VPN topic, I always do the port forwarding topic, okay? And the reason is because the port forwarding is really like very much a poor man's VPN, right? So it's got a lot of those elements if you think about it. All right, so this looks a little bit busy. Let's just move to a new slide, but let's think about it. All right, so you have here, if you look at Mitch's video, right, and you configure the first thing, Mitch configures in his video a router, not a firewall, first of all. So, but it does have two network interfaces set up, and then you have two computers. That's the simple element. Now we said these were 192.168.10. 10.1. And this one was, I think, 192.168.20. So then you have some internal computer, 192.168.20.7, and another one, 192.168.10.9. Now there could be a switch here, obviously, you can have more computers, but we're just going to keep this simple. Now another assumption here, any traffic will be allowed through basically in any way. Pings, HTTP, whatever it is, telnet, etc., they'll be allowed to go through. Now we did say that to make it into a firewall, you have to kind of get rid of this, and make it into a firewall. It has to, and instead, maybe I should have drawn it like this, right? Instead of putting in, a firewall like that, just make sure you put on one side. Which side do you put it on? The less trusted. So here, oops, sorry. Here we're gonna say, we're we're going to say that this is the less trusted. So, this just represents the web, the insecure internet. This, on the other hand, would be the more secure, so it represents the inside, right? So it's the inside network. Okay, so now then, as I said, in port forwarding, all traffic, you should really allow all traffic going out. So that's okay, but you deny all traffic coming in. That basically is a firewall. All right. Now, the issue is, with port forwarding, we open a little port, and that port can be reached through, and then you can reach the internal network through that. However, you probably know that that's not very secure, right? So you don't really want to do that. But port forwarding does motivate, the idea of a VPN, which is a virtual private network. If you think about it, it's a virtual private network with a lot of things now. It's going to have the routing, which is the tunnels. It's going to have the crypto, and it's going to have more authentication. Okay, so it's got more elements that this port forwarding does not really have. This port forwarding has, the routing basically, but not anything else. Okay? So now we want to think about our scenario where we have a remote worker. So this is somebody on the internet, maybe working from home. And what they want to do is they want to get on the inside network, because the inside network has some files that they need, right, to be more productive. So if you just did the port forwarding solution, they might be able to get to that server that they need, but they're very limited. So what if they need no longer a web server, but they need an email server? Okay, I'm going to punch another port in there, and then they go in that way. Okay, what if they need, something else, SSH? Okay, I'm going to open up another port, and it just becomes impractical, right? It becomes impractical to do it that way. So we have to rethink our approach. And so our approach then now becomes the fact that we want to make this firewall also into a VPN, a virtual private network, with maybe one port, and that port allows everything to go through. Do you guys see that? So the way that you can think about it is, instead of having all those ports open and all those rules in IP tables, it might be better just to have one generic port, right? But that generic port does not directly go into inside. Instead, before it goes to the inside, you're going to take whatever comes in here and you're going to direct it into a program. So let's just say code. You have some code in there, right? And so what you want to do now is you want to take what, remember, these are just packets, right? So they're always packets. So a packet comes in through that one port instead of all those ports. It does not go inside or anything like that. It goes directly to this code. This code, as you might imagine, will have a whole bunch of if statements, etc. It's C++ code. And it'll do a lot of processing, and then decide, okay, what do I do with that packet? Do you guys see that? And so that's the question. How do you do that effectively? Okay, that's the question. How do you do that effectively? Well, as it turns, because if you think about it, if we take the packet and we send it to the code, and then we have to deal with it as a string or as a byte array or something, it just makes the code much more complex. But what if we had an alternative where we can just take a packet that we receive, and pass it through some interface, some new interface that actually allows you to deliver the packets directly into code. So it would treat the code as another machine, if you will. And so it just redirects the packets into it, okay? And that is TuneTab device comes in, okay? So TuneTab. Okay, so that's really what we're going to talk about today. All right, so but I just wanted to make this connection between port forwarding and the VPN. Okay, so hopefully that was clear. Are there any questions on this, guys, so far? All right, doesn't sound like it. So anyway, so okay, great. So that's the connection to port forwarding that I wanted to make. And now that you hopefully understand that, I might ask you on the exam, like, what's the difference between port forwarding and VPN itself? But now let's just think of VPN itself. So let's go over here. And again, remember, we're just kind of thinking about this from scratch. We're not thinking about this, just some application where we press a button. So again, now, this is our VPN. Okay. And now, if we think of the network that we've been referring to all semester, right? We have switch 1, switch 2, switch 3. Here now, you kind of understand this, right? That's the firewall now. And then now you do have also maybe a router. And then like this. And then you have your remote worker in the internet somewhere, which is not trusted. It could be an employee, so remote worker. So now what they want to do is, because there is the firewall there, it does not allow anything from the outside in, right? But in this switch, there are a lot of resources, a lot of servers that this remote worker wants to get, okay? So what needs to happen then is, the remote worker usually can get through and it'll hit there, right? It'll hit there, and with port forwarding, we would just use the port there. However, now we can't do that because port forwarding is insecure, and therefore we have to provide VPN services, okay? But with the VPN services, what ends up happening is that the remote worker on his or her computer will create a virtual interface, right? Interface. And that virtual interface, basically it becomes as if the remote worker was connected here. So if I call this, RW, right? Remote worker. Once they connect, it's almost like they're there. You see that? They get an IP on that virtual interface as being in the network, but it's all virtual. It really is, they're going through this. And whenever they hit the VPN, they need to authenticate, okay, all the traffic and get approved in, okay? And the VPN will have a lot of functionality to allow that through, okay? So that's the idea. So how could we do this, in our environment, right? So we can go over here. Let's imagine that we have 3 VMs. Again, remember this, you need to configure this in workstation. They need to be on the same network. The 3 VMs need to be able to ping each other so that they're there. And then you need to do some configurations, okay? So we're going to think now of another scenario where we have a web like this, right? And then we have 2 computers, right? Now, to simplify things, we can just assume that this is, even though this is supposed to be the web, obviously, to simplify things, just make sure that's the same switch, okay? So on the outside, the interfaces could be the 10.0.1.1 and 10.0.1.3 or something, right? So these interfaces are on, it represents the internet technically, but maybe I'll write it here. It's like the web. But basically, when you go here, you can ping. So from 10.0.1.1, you can ping 10.0.1.3. From 10.0.1.3, you can ping 10.0.1.1. No problem. Now, the other issue is on this side, right? On this side, you're going to create another network. another network, and on that network you have another device. Okay, so here we can say this is another network. This could be, for instance, a NAT network in VMware. This could be a host network for a machine. It's really up to you guys. But this machine, what's important here is that this is another network, the 192.168 dot, let's say, 3.0 network. 0. So that means this could be 192.168.3.1, right? And then this one would be 192.168.3.12, something like that. Okay, guys, so you have your machines there. Now, what are these machines, these two? Well, they kind of represent, you know, the VPN device, right? So they kind of represent the VPN device. And so we can go over here. And now we can say this is the VPN client. And this, oh, I should have made this bigger. And this is the VPN server. You see that? Those are the devices that allow you to connect. They provide the functionality of creating the VPN. So then here, possibly, you have another computer. So now let's call this computer U and this computer V. You see that? And so what needs to happen is that this computer ends up in this network, for instance, or vice versa. Okay? So the question is, how are you going to accomplish this? Okay? So that's really the question. And so one of the things that we're going to take advantage of in Unix is something called the TuneTap network. So just like this has a network interface and a network interface and these network interfaces, right? Here we create virtual network interfaces. So here we create what are called virtual network interfaces that allow us to do this, the tunneling. And this is a feature called a TuneTap in Unix. Okay, this is what's going to help us to accomplish this. Okay, any questions so far? Okay, not hearing any questions. All right, so what is then TuneTap? Let's provide a definition for that. So what is TuneTap? So these are, as I said, these are virtual network interfaces. Okay, they will allow us to create the tunnel through routing. And that's really the trick, is that you'll see how it's very clever, but you just create a series of routing rules. So tunneling creates a tunnel through routing. Oops. And then once we've routed the packets through this, we're going to add the cryptography. Okay, because if you remember, a VPN is basically just, made up of basically tunneling, and routing, and the crypto. Okay, now the problem is, as I said, when I was comparing this to port forwarding, is that we can't open a whole bunch of ports. So if we just have one port, how do we handle all these different packets that we have coming in? And so there's no way around it. We need to have some code in there, right? So remember that for this, we can't use Python because Python is too inefficient, right? So instead, we have to use something like C++. But the great thing about this lab is that the C++ code is already provided for us. We just have to kind of modify it a little. Okay, so now if we think about our scenario, here is the routing of it, right? So let's think about it. So routing. Okay, so we are going to have now, let's imagine we have the web here, and I need a lot of space for this. It should be enough. So I have web here. Let's imagine I have a device here called a router. And I have another device here, the router. Okay, now I'm going to have, now let's simplify this by just thinking that we have here a switch, and the switch has two devices. These are just Linux computers. Think of them as VMs, you know, whatever you want. These are just, you know, VMs, let's say, Linux VMs, or just VM, let's say. This is another VM. And then on this side, same thing. We have some kind of a switch, and then we have two devices here. And these are also VMs, Linux VMs. Okay? All right, so now let's think of the logic. First, we need to specify a network. So this is going to be the 10.0.7 network. So this is 10.0.7.1. And then this one is going to be 10.0.7.8. And then this one could be 10.0.7.5. You see that? We have that network. Now we're also going to say that this is a regular machine U, and this is the VPN client. So now we're changing a Linux box into becoming a VPN. We're not thinking about how we're doing it yet. We just want to understand the routing implications of this. How do we do all of this, right? On the other end, we have the router is the other network 10.0.8.1, which means that this one would be 10.0.8.5, and then this one could be 10.0.8.8, let's say. Okay, so we have our scenario here. Now let's start the process. Oh, and this will be V. That's the other computer. So these two computers, U and V, they want to talk to each other. Okay, U and V. And then this one can be the VPN server, let's say. Just two ends, right, of the VPN communication, basically. So now I'm going to switch to a different color. And now let's say that U starts the communication. So U sends out a packet. There it is. And the packet basically is going to the 10.0.8.0.24 network. Let's say it wants to go to 10.0.8.5. You guys see that? So that's the first thing, right? So what do you do there? Well, the first thing is this machine, U, knows the 10.0.7 network, right? It does not know, let's say, the 10.0.8 network. So whenever it doesn't know anything, all it does is it's going to forward this to its gateway, which in this case, the gateway would be 10.0.7.1, right? So the router basically would be its gateway. So the router then needs to decide what to do, right? What to do with the packet. But the packet needs to be encrypted. It needs to be, it can't just like, oh yeah, you know, it could send it, But then that's more like port forwarding, right? It's not really a VPN because it would send it in the clear. So it needs to go to a VPN. Now, the VPN could legitimately be inside here, right? But I have deliberately put it outside just so that we kind of, treat it as two separate features as they are. So then the packet, you don't know what the packet is, where to go, so it's forwarded to the router, right? The router receives it, and then the router needs to know what to do. So the router could send it out, especially because it might know this outside network, possibly, right? Or it doesn't. This could be a 192 network, for both of these, right? So it could be separate. So what does it need to do? You need to have the first item will be a routing rule. Okay, so for the routing rules, I want to use a different color. So let's say here, it's going to say, so think of the routing rule as if going to the 10.0.80.24 network, right? Which this one is going to the 10.0.80.24 network. It is going there, right? So the question is, remember, this is a rule, by the way, in the router. That's a router rule. So the question is, what do I do with that packet? Well, the packet needs to be encrypted. It needs to follow some specific, requirements. Therefore, I send it to the VPN. So if that's the case, then send to, what's the VPN? 10.0.78. You see that? That's basically the routing rule there. So it arrives at 10.0.78, okay? Now 10.0.78 has its own 10.0.78 physical interface, this one, but it also conveniently has a tune tap interface, right? A virtual interface, okay? Very much like VPN server also has a tune tap interface. Why is this important? It's important because remember that VPN client is a VM, but to be able to do all the VPN functionality, it needs to have a VPN application, okay? And the VPN application will be listening on the TuneTap network. So let's say this is the code, okay? That's the code. So then now remember, this machine or any machine in this network wants to go to 10.0.80, let's say 10.0.85. It hits the router says, okay, I need to forward this to the VPN. Now the VPN could be inside of the router, perfectly valid, or it could be another device on the network. So in that case now, what happens is that the router then sends the packet to this machine here. This machine receives that packet, and now what's the issue? It needs to know what to do with it, okay? It needs to know what to do with it. Well, as it turns out, that's also a routing rule. So I'm gonna have to erase these from the VMware. Okay, so now it's gonna say, well, I need a routing rule. And what's the routing rule? Because I just got this packet, right? I just got this packet. I need to know what to do with it. So I need to have a routing rule for it. And I'm going to say if going, I received this packet, right? It arrives here. It's the same packet here. It just arrived. And I'm going to say if going to 10.0.80.24, right? That's exactly where this one wanted to go. So if it's going, this is a rule in this VPN. If it's going there, what do I do with it? What do I do with it? I send it to and where do you guys think you would send it? What would you guess? Guys, where would you send this packet? You send it to the tune tab, right? So you just send it to tune tab. Why does that work? Because when you send, so now the packet gets redirected, and now it ends up in your code. Do you see that? And that's how you end up basically with all the routing rules, and you end up, the code then can process the packet, it'll receive it as is, and then it can proceed to encrypt it, to authenticate it, to everything, and then it's gonna know how to send it out. Use yellow. So now it would know how to send it back out to the other network. You see that? That's basically the idea. On the other end, we can do the same thing, right? So we can do the same thing on the other end. So now on this side, let's take the same exercise. V receives a packet, right, from this network, and now it needs to return to that network. So then basically 10085, right, needs to send it back out. Now remember, once it's in this network, it's like a regular packet, right? Because it comes here, the VPN, the code will deprocess it and put it in as if it was the packet here. The response packet then leaves here, right? And it's going, let me change to green. So now you send out a packet, and this is going to say, now I want to go to the 10.0.7.024. Okay, so you send this back out. All right, you send this back out. What is the 10.0.7 network? That's this network, right? That's that network. So it's the same thing. This is 10.0.85. Okay, so this computer does not know that network. So then what does it do? It sends it to its gateway, right? So the gateway for this one, for V, gateway for V would be the 10.0.81, correct? So it's going to send this packet to the router. Then the router, again, will do the same thing. It's going to ask itself, okay, it needs to have a routing rule. It says, if going to the 10.0.7.0.24 network, then I need to send it to the VPN service. Now the VPN service, again, could be on this router, but here, just for more clarity, we've actually placed it outside. And this is common, like if you guys set up an open VPN, for instance, or something like that. So Linux has OpenVPN. So then you can do, if going to 10.0.7.0.24, then forward to the 10.0.8.8. What is that one? This one, the VPN server, right? So then again, the VPN server will receive the packet. So then the packet, kind of arrives, gets forwarded back, it arrives here, right? And then, but now the VPN server needs to figure out, what do I do? Okay, so it needs to have a rule, a routing rule, right? And what does that routing rule say? Well, if going to, where is it going? 10.0.7, right? So 10.0.7.0.24. You see that? If it's going to that one, what do I do? Oh, okay. I need to send it to, and where does it send it? This is the mirrored image of the other side, right? So where does it send it? All right, so it's going to send it to the TuneTap interface. Which TuneTap interface? Its own TuneTap interface, right? Again, this TuneTap interface is connected to what? To some C++ code. And the C++ code will take the packet, which is kind of all in clear text and everything, and it's going to do the whole encryption process, right? And then it sends it out into the network. Okay, guys, so that's basically the idea. Now, if you had something like a Cisco ASA and everything, a lot of this is done automatically, right? A lot of this is done automatically by it. But if we're building this from scratch, we kind of have to think of every single routing element. And of course, we haven't even discussed the code itself. So we'll take a look at it. Should be pretty interesting. Are there any questions on this one, guys, on this slide? Are there any questions? Okay, no questions. All right, so now that we've talked a little bit about that, then let's kind of imagine that we're going to zoom in a little bit into this, right? So it's like we're going to like zoom in. I can erase this. So we're going to zoom in into that one, or we're going to zoom in into that one, right? So we're going to zoom in into those. So let's take a look then over here, and let's learn a little bit more about what TuneTap is. And as you know, Linux is a generic way of doing everything. So in the firmware of Cisco or those companies, they'll have something equivalent to this, but that they probably implemented by themselves. And that's why their code is called firmware and not something else. All right, so TuneTap, actually, the name means two things. It's not one thing, but it's actually two things, okay? So it's two interfaces, if you will. It's very powerful, actually. So if you're ever looking for a project, you want to learn a lot, this is definitely something to look at. There, as it has been stated already, let's just, other virtual interfaces. Virtual interfaces. Okay, and they're used to create, virtual network interfaces. But the key thing is that I want to even write down clearly here is that it connects a network adapter, or should I say? Let's say computer. So a network computer to a program. So it's almost to a program. On your machine, on your machine. Oops. So think about this. So usually when you have a network interface, right, it's almost like it connects two computers together. Oops. Right, so you have a computer with a network interface and another computer with a network interface, and that's what happens, right? But the TuneTap does something a little bit different. It does some, it's almost like it does this to code. You know, a C, C++, where the program is actually running on the same machine. So it's almost like it's a connection to itself, right? It's almost then, see, this is actually, the code is there, and so it's almost like that. You see, it's a connection to itself. Leave this like that. You see that? So that's the logic behind it, if you will. Okay? So that's what TuneTap does. You know, as opposed to a normal network interfaces, TuneTap allows you to connect to code, and by the way, to your own code. Okay? So, and the code is, sometimes you can think of this code as code pretending to be a computer. Therefore, it receives the packets as another computer would. You know, packets arrive exactly as if it was another computer. So you can see here then we have a switch. We have the real PC, let's say, right? But then there's some code in here, some C++, and then this has the TuneTap interface, and then that TuneTap is connected to that. So this program, that program is pretending, basically pretends to be a computer. Okay? And so, and in particular, it gets packets, you know, normal network packets. Okay? And so we're going to use only one of the two interfaces. There's tune and there's tap. So really, we only use tune. So we only need to use tune. We do not need to use tap. This one, you know, we don't need to use it. Now, now the difference is that this works on the IP level, whereas this one works on the Ethernet level. So if we think of the OSI model, this one works more at the physical layer, whereas this one is more, you know, at the IP layer, right? So a little higher. What's interesting about this is it allows you to do more, right? So obviously, because you know you're basically at the, I'm sorry, you're basically at the physical layer, so you can do a lot more, right? On top of that, so you can do more with this. It's very powerful, so you can do a lot. However, that's not what we are doing. You know, we just need a VPN, so at the IP level is fine. So the tune will deliver, so tune delivers IP packets to the C++ program. Okay? And then, as I said, tap works at Ethernet level, and it's more like physical interfaces. So finally, all that I have left now is just to go over the commands that allow you to set this up, right? So let's take a look at commands or programs. So now think there's two elements here. There's going to be C++ code that needs to be compiled, right? And then there's also going to be the Linux commands. Linux commands. So in here, then, in Unix, let's say, so in Unix, I'm almost done. We can bring up can bring up TuneTap. In a couple of ways. So we can do, so we can use, there's a function called IOCTL, right? And you know, a command, a function. This can work in C, C++, or terminal. And it's the same, right? So it's basically a command that allows you to set up TuneTap. So if you remember from your 372, everything in Linux is a file, basically, even devices, etc. So what it does is it creates this handler or reference, and it opens it up in the dev folder. So in dev, so in /dev net, it'll create an interface called Tune. Okay, and this is actually the device. The TuneTap, it already exists, right? So it's already there, but it's sort of sleeping. You wake it up, and then you register it to the Linux kernel. Okay, so by, you know, bring it up in Unix. Okay. Once you do that, it's like you enable the interface, but it's not configured yet, right? So you still need to configure it, and to configure it, you know, it's very, very much at this point though. This is like a network interface, okay? Like a network interface. So that means that you can configure it just like you would configure other interfaces, right? So now you go to the terminal. So if you want to show the device, all devices, obviously, ifconfig-a, right? That'll show you the TuneTap, but it won't have any parameters. So this is just to show. Now, if you want to assign an IP, what do? You can do, you know, sudo ifconfig tune 0, because it's going to be the first, you know, tune 0, and then you assign it an IP. So for instance, 10.08.25, you know, /24 up. You guys see that? So this is just some IP that you can specify. Then again, if you want to see it again, you just do ifconfig, and then you'll see it now configured correctly. Okay? All right, I just have one more set of notes here. So then the last part is, we saw in the slide here, right? I talked about routing, but you saw that I just wrote, like, you know, very much like pseudocode almost, if, you know. So now, how do you actually do routes in Linux? Okay, first of all, so let's call this Linux OS routing. First of all, number one, look at the video. I just posted, you know, Mitch's video that he did. That video has a lot of examples on how to, because to get all those machines to work, you have to actually set up some routes, right? So definitely take a look at that. Number two, that'll help you a lot. Number two, here are just some of the commands. So what are some, so now we're talking about, let's talk a little bit about routing tables. And we'll finish up with this. So routing tables. Okay, so one thing about routing tables is that they're like IP tables, right? So IP tables and routing tables have a similarity in the sense that routing tables like IP tables are sequential. So that should be obvious to you by now, in the sense that you know that once it hits a rule, it kind of stops there and it doesn't continue. Okay? Now, what is the routing command? Basically, you go to the terminal and you type route. That's your command. Obviously, you will need the sudo privilege for that. All right, so the last thing is, let's say that you have a rule, right? You have a rule. So let's take an example. We'll conclude with this. And the example is that, you have a goal of if destination is 10.0.80.24, right? If that's the destination, then redirect to the tune 0 network, right? So that's very similar to one of the rules that we did over here, where we had here, right? So if going to 10.0.8, send to tune tab. Okay, so now in Linux, to do that in the terminal, you would just simply say sudo. You know that you need the sudo privileges for this. Route add -net for the 10.0.80.24 network, send it to tune 0. And that's it. You want to view the routing table, you can always do, probably don't need sudo for that, route -n. Let's just say to view the table. And that's it. Okay, that's pretty much it for today. Make sure to take a look. So, your homework, well, you have plenty of homework, but one recommendation, look at the video that I posted. It's got a lot of examples of using route. Okay, and that's basically it for today. So at this point, I'm going to stop the recording.